It's a lot easier to take nagging from a robot than from a family member. So it's beneficial for everyone.
Welcome to ChatRog, the podcast on ethics in artificial intelligence. I'm Roger Steer, the corporate philosopher. Today, we're joined by Natasha Allechina, Professor of Safe and Responsible AI at the University in Helland. She is an expert in the logic and ethics of AI. Her work explores one of the most difficult and fascinating questions in artificial intelligence. How do we design machines that act not just intelligently, but morally, especially when they're caring for people living with dementia? Natasha, welcome to ChatRog.
Thank you very much for inviting me. Very happy to be here.
Thank you so much. So let's start off with some questions about you and your background. What first drew you to the question of ethics and AI, and particularly to its role in dementia care?
I've been working on safety of AI systems for many years. I started in early 2000s. Most of my work was to prove properties, to guarantee properties of systems of autonomous agents. And some of them were safety properties, some of them were just liveness properties that agents can actually achieve their goals, because you can also achieve safety by freezing everything and nothing can move. It's very safe, but
yes,
not very useful.
Like putting the handbrake on in a car,
yes.
Nothing moves.
Yes. So that was my work until quite recently, when I started to get very interested in guaranteeing behavior of machine-learned programs, things like reinforcement learning agents. And it's very difficult because they're not programmed explicitly. They learn to achieve their goals. So unlike the classical AI, you cannot just put something in that stops them doing unsafe things or anti-normative things. In learned systems, you have somehow do it in other ways, and that's what I was studying lately. And finally, with the emergence of generative AI and its very rapid uptake, I began to think that in addition to just trying to make safe programs, it's also very important to guarantee that the AI systems are deployed safely, that somebody takes an off-the-shelf generative AI chatbot and want to use them for some very good purpose. We still need to study very carefully, would it actually cause some problems for the users of the system, for the society as a whole. So that's very briefly my path through this research in safety of AI and responsible use of AI.
Thank you. And you said that goes back to 2000. So you've been working in this space for a lot longer than many people, haven't you?
Yes.
So you spent much of your career working on formal models of trust and responsibility. How do these ideas connect to real-world caregiving robots, for example?
At the moment, the project I'm involved with Ruslan Leontiev's that you interviewed on previous podcast, the robot is not doing physical care of the dementia patients. It is there to basically entertain them, calm them down, cheer them up, just to provide companionship. And it is a very good aim, and I think the current version of the robot works very well. I heard very good reviews of it. It doesn't use any generative AI. It tries to make the content suitable to individual users. Some people find music more agreeable, others find games or movies more agreeable. So it does try to cater for individual users, but it doesn't try to engage them in conversation.
That's so interesting, and I'm delighted that the limitations of large language models are something that you and your colleagues like Ruslan are fully aware of.
Yes.
Because, of course, we're aware of horror stories of how conversational chatbots and therapy bots and companion AI, for example, can create all sorts of problems because of the limitations of large language models. Could you please explain for the non-technical listener, perhaps the difference between the sort of AI that you are developing and overseeing and ensuring is safe, and the large language model, the generative AI that you referred to earlier?
The classical AI that started as mostly rule-based systems, you could still get the rules wrong and cause some problems, misdiagnosis, for example, if you capture the expert knowledge incorrectly. But they're a lot easier to inspect and see how they work. With reinforcement learning, that is robots that learn by trial and error to learn how to pick something up, because it's very difficult to implement as a system of rules. You just have to try and find the right kind of position of the joints and the force to grip something. You could still, as I said, impose some kind of constraints on this process, that you're never going to wave it too far or shove it into the client's direction very hard. So you can impose this kind of constraints, and within them, the robot learns to do particular action. With generative AI models, they are trained on an enormously large corpora of text, everything from the internet, everything. And it's very, very clever systems. They have amazing performance. But basically what they're doing, they have a very compact representation of all this text that they have seen, and they try to do the most plausible thing. So they predict the next word for the prompt, and then use the prompt with the next word to produce the next word, and so on. And they can write text, they can write programs, because on the stock exchange there is everything. There is a lot of problems, a lot of code to solve those problems, and an explanation from some good programmer about why this program is like that. So they learned all that. They sound very plausible. They're also designed to please the user, to say what the user is probably wanting to hear, and to talk as long as possible with the users. So it is fine if you just want to cheat at your coursework, basically, to produce some plausible text. And only the poor professors are a bit stumbled and think we should think of some other assignment to do. But if people start to discuss their problems, if they feel very down, they consider suicide, then this thing is just going to help you. It's going to please you, it's going to explain to you how to do it, and unless there are guardrails in place, but guardrails are very difficult to do. And that's another thing that is a big challenge to people like me, who try to extend techniques from previous age of AI to verifying, or at least monitoring, the performance of large language models, is that it's very difficult to specify what is it exactly that they shouldn't do. I mean, on a high level, it means that they shouldn't do harm to people, or they should respect their dignity, and they should respect their privacy and things like that. But how do you translate it into precise sort of monitoring of the words that they are saying? How can another computer program detect that something bad is happening, that something is violating this very high level, very imprecise, informal requirement that they should comply to? It's very difficult, and that's a very big challenge. And that's why the guardrails are kind of hit and miss. Sometimes they just rule out absolutely everything. So I'm now actually in Manchester at a workshop on formal ethical agents and robots at the University of Manchester. People here are discussing how to make AI ethical, how to actually specify what it means to be ethical, how to get programs to reason about ethics. So ideally what we would have is that something sitting next to a large language model would be saying, okay, what they're now suggesting is going to lead to harm to the person, and stop it.
That's absolutely fascinating. So just going back a little bit on your answer, there is a fundamental difference in mathematics between the generative AI, which is probabilistic, and the sort of AI that you're working is, which is, shall we say, much more predictive in so far as it's rules-based. Is that a fair explanation, or have I not got that quite right?
No, not quite right, because reinforcement learning, which is what I said about learning the movements by a robot, learning to walk, learning
Mm-hmm.
to climb stairs, learning to grip things, that's also stochastic.
Okay.
The actions may fail. We all sort of drop things. The environment is not completely deterministic. So the robot tries to move a step forward, it slips, trips, it falls down. So that's also stochastic. But it's a lot easier to specify that you should be moving forward. It's a very
Sure.
simple mathematical
Yes.
problem.
Yes. No, I get that now. Thank you. And you just said something there which caught my attention, which is basically having the sort of model you're developing almost as a guardian, rather like a young child learning to walk. There's a parent or a guardian nearby to make sure that if they fall, they can be caught before they hurt themselves. Again, is that a fair, simple understanding of that?
It's one of the approaches that the one that I think is most likely to succeed is, instead of fiddling with the large language model itself or even with the wrapper around it, the user interface that allows you to sort of put prompts to it and get the response. Then rather than to do that, we just get this guardian. That's an approach in computer science called runtime monitoring. And when you cannot verify something completely exhaustively, you at least provide it with a monitor which tries to look a little bit ahead and stop it when things are getting dangerous. They use it in nuclear robotics and other places like that. Just something that is watching and trying to predict what's going to happen and do something to stop it.
Thank you. That's much clearer now. So you mentioned Ruslan Leontievas, and you work on projects with him like Sarah Plus and Noah, which he explained in a previous podcast. So from your perspective as an AI safety ethicist, what makes these systems distinctive, would you say to the listener?
I think it's a very interesting development in the use of AI. If we can make it both safe and at the same time beneficial for people to have these companions. And there is already very promising work in other countries, in other labs, on exactly this kind of robotics, not the one that helps people to wash and get into
Mm.
bed, that gently nags them, for example, to do exercises if they had a stroke. It's a lot easier to take nagging from a robot than from a family member. So it's beneficial for everyone.
Yes.
The work on Sarah Plus and on Noah is also in this direction, that we relieve the caregiver, family member, or the attendant in the old people's home from some of this quite hard work of just trying to nag people, trying to get them to do something, trying to entertain them when you have several people to pay attention to at the same time, if we can do it without causing any harm to the patients. And the harm could be, like you said, getting them to be more depressed than they were to start with, or actually insulting their dignity if they think that they're being infantilized. Or there's lots of possible things that could go wrong, and my duty in the project is basically try to think of it and try to measure how we can counteract it.
So that's a very interesting insight. And so are you deploying software which can detect stress and distress in a patient's voice? Is that possible? I mean, how do they know if the nagging is doing its job and they are cleaning their teeth or whatever it is, or it's resulting in some distress? How does that work?
I think Noah's idea was in that direction. So far, I don't think we got there. There was a work, the one I mentioned about rehabilitation of stroke
Yes.
victims. I think it was Maya Matarik group in the US. I think they just realized that the person they were interacting with was cross when they started to shout at it.
I bet.
But they also tried to learn what works and what doesn't. I saw quite remarkable videos of the robot slightly changing approach depending on with whom it was talking. Sometimes it was very cheery, and I just showed them how to do exercises and just made them laugh, and eventually they would snap and also stop. And sometimes
That
it was very different.
makes sense. Humor is such a, positive humor is such a powerful force, I would imagine, in these situations. And of course, dementia patients can have good days and bad days. They can have very lucid periods of time and so on. So again, that must be quite a task for your robots to be able to pick that up. Are they having a good day or a bad day, for example?
Yes, it's very challenging problem. There are various machine learning approaches, not generative AI, but just trying to learn from a particular person how they're feeling, whether they are actually open to interaction or not. But it's all slightly hit and miss because even we people sometimes have difficulty, right,
Of course.
in reading each other's expressions and behavior. So AI can't do much better, I think, but there are some very promising projects in this direction.
Oh, I would imagine face recognition software is able to read emotions in the face that may not be verbalized, for example.
People are trying to do it. It's very dependent on a training set. Most volunteers who were making angry faces at the learning program were young white male students. So it's pretty good at that. It might have completely different results with people from other cultures. A well-known thing is, for example, that people in China and Asia sometimes smile if they're embarrassed and frightened. So if you train it on American college students, it would misrecognize it completely.
And I can imagine the same thing is true, for example, in other cultures like the Indian culture, where I can't quite remember the right phrase, and apologies if I offend anybody, but the head wobble can mean yes or no, for example.
In Bulgaria, they say yes,
Yes, yes.
even close to home.
Lovely, lovely,
I was once trying to play poker, partnered with a Bulgarian guy on the beach, and it didn't go well at all. All our
lovely.
attempts to signal things were just completely opposite.
Yeah, as you say, it's difficult enough for human beings to do that. And we've got, hundreds of thousands of years of learned programming there. So as a human ethicist, I'm interested in how you build ethical reasoning into these technologies. Is this something that can be programmed? Or as we've discussed, is it just as much about the context in which they're used? Or is it both?
It's both, and I just heard very nice tutorial by people who know more than me about machine ethics. They divide ethical AI approaches into kind of external and internal ethical agents. So external ones, like what I'm working on, somebody thought about what ethical behavior should be and either trained them with this constraint in place or programmed it into them explicitly, and they obey the ethical behavior according to my lights as a developer. So they don't reason about it. They don't know why they should be doing it like that. They never think about why they should be doing anything. They just work in an ethical way as far as I'm concerned. And then internal ones actually reason about ethics. And that's a lot harder, but you can implement it at least in rule-based systems. You could get them to evaluate alternatives. So I can do A, B, or C action. A would cause this, and I know that this is bad, like a human falls into a hole. I can do B, in which case I will distract the human and they won't fall into the hole. Okay, ethically, this is better. So that's how you can try to implement it.
Okay, thank you. We're going to move in a moment into how you resolve some of these conflicts. But one of the things, as you and your colleagues will know, is that a lot of ethical reasoning, moral reasoning in human beings is driven by emotion. So emotions such as compassion, which is positive, or disgust or shame, enable us to make difficult decisions. I guess what I'm saying there is they're not very rational or logical by definition. So how do you and your colleagues attempt to incorporate that aspect of moral reasoning into the decision-making systems that you're developing?
There are different approaches to this. I am working in the direction which doesn't use emotions. It could be a feedback to the agent if they can spot human emotion, that I'm really annoying this person now, my behavior is counterproductive.
Exactly.
That is important, but that's not about the agent's own ethical behavior as such. Agent itself doesn't have emotions. Some people
Of
try to
course.
implement emotions in artificial agents, and it is quite difficult because we can't even agree exactly what would it mean for an AI entity to have an emotion. This very simplistic approach, maybe just to say, okay, it had a goal, it failed to achieve the goal, it has an emotion now, it's disappointed, frustrated. Maybe you can build on that and go further. But I think for ethical AI, it's more important that AI agents can spot what emotion their human collaborators or patients are experiencing than to try to create an emotion inside the agent. The agent could just have values, ability to judge, and ability to choose the most morally appropriate action.
Yeah, I mean, that's a really, interesting thought. Again, as you and your colleagues will know, there are, one of the classic approaches is the utilitarian or consequentialist approach, which is effectively the right action is the one that creates the most good for the most number of people. But there have also been criticisms of that philosophy, that moral philosophy, in that it actually is really bad for minorities, that it justifies the most horrific human crimes, genocide, for example, and so on. So is that something you're looking at in terms of avoiding the pitfalls of that very simplistic utilitarian approach to moral reasoning?
Definitely, it's very difficult to formulate moral values, ethical judgment. I think it should be as open as possible and definitely not, oh, it's always better to kill 5 people, sorry, vice versa, not to kill 5 people by
The
killing another
trolley
person. Yes, the trolley popped up today a lot, but then the alternative version, which you probably heard about, that there are 5 transplant patients who would die if they don't get the transplants, and a doctor sees a completely healthy patient who has all the necessary parts. So should the
organs.
doctor
Yes.
bump off this person and save 5 other people?
Horrific.
Nobody says, no, 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 obviously not. So no, I don't think utilitarian version is very convincing.
Indeed. Again, therefore, maybe we should be maintaining some sort of human oversight to these systems. Again, is that an angle that you and your colleagues are looking at? So not to have purely robotic systems, but to have some level of oversight. We can see that in other applications for AI at the moment.
Yes, definitely. If it's decision support systems for the government, inland revenue, for other things, then it shouldn't be autonomous AI system just makes decisions and carries them out. There should be human oversight. The robots that we were talking about are the ones who keep patients with dementia company and entertain them, and the whole point was to free the human attendant for even maybe short periods of time, but they wouldn't be watching all the time what this thing is
Yeah.
doing. It
Yeah.
should be safe enough to leave it there for half an hour. Obviously, I wouldn't think of sort of locking a bunch of dementia patients with a AI assistant for a day. So there should be somebody there who can intervene if the patient gets upset or things don't work out. This kind of assistant only makes sense if they could be left without human supervision for
Thank you.
maybe not very long time, but at least should be safe enough to do it.
Yeah, that absolutely makes sense. Thank you. So, when we talk about a trustworthy AI system, what does trust really mean, do you think, for the users and the human overseers? What makes a system, what will make a system trustworthy, in your view?
It's a very deep question. I think it depends on the context and the purpose of the system. If it's purely entertainment provider, then to be trustworthy, it shouldn't upset people. It shouldn't create harm, as an emotional harm, and it should be secure in the sense that people would tell it things, maybe it would record them or it keep some kind of visual data for a bit, that it should be safe from being hijacked, published, stolen, somehow misused. It should be also secure from somebody hacking into it and talking to the person pretending to be a program. But that's kind of very small part of what trustworthy means in general. If it's a system used by the government for making decisions about citizens, then lots of other things come into play. It should be fair, it should be explainable. If it makes a decision about somebody and it's against the wishes, then it should at least explain why, and why them, and why not somebody else, and things like that. So there are lots of aspects to trustworthiness, and it's both in this explainability, robustness, not creating any harm, safety, and absence of discrimination of any kind of bias. So it's very many aspects to it.
Thank you. So, who should be accountable when AI systems are used in such sensitive settings? We've got developers, the care providers, the organizations that deploy them, the families of the people in care, and so on. How do you think that accountability and ethical oversight should be shared?
I think it's between developers and people who decide to use the system in the medical institution. And there are many standards for medical equipment already in place, but so far people only are worried about that the medical equipment works incorrectly and could, I don't know, leak, burn, damage the patient in some other way. So I assume that when this kind of thing goes wrong, like the MRI machine malfunctions, then the onus is on the manufacturer of the machine. Um, Although if it was a very experimental device, then responsibility is probably divided between manufacturer and the hospital. In our case, there is also emotional damage, which nobody had yet implemented a standard for. I think people are working on it. So again, I would say once the system had been specified and evaluated, and the manufacturer or developer says absolutely safe, we guarantee that nothing would happen to any patient, and then AI system goes and drives somebody to suicide, then I guess it's developer's fault. Although again, maybe the medical institution that took a risk on some slightly dodgy new innovation might share the blame.
That's really interesting. I mean, today, in terms of dementia care, there tends to be a situation where families of the patients in dementia care almost seem to absolve themselves of responsibility for their relative. And when something goes wrong, they just blame the institution, which is a little different from other aspects of our lives when us, the users, or if it's children, the parents of the users, we expect them to take responsibility or part of the responsibility for the safe use of technology. Do you think there's an element there that we're missing in terms of making sure that the families of patients in dementia care need to understand what's being deployed and need to sort of share some of that responsibility?
They definitely need to understand what's being deployed. They should also be involved in actually developing these things. We are planning to have a user group that would provide input to development of the software, because we may miss some important things that they think should be done or important things that could actually be harmful, just because it's very hard to imagine all possible situations when at least Ruslan and I are not actually daily concerned with dementia care. So I think the only way they could get some of the responsibility for this use of AI assistants is if they are involved, committed, and understand what it's doing. Otherwise, it's like blaming the parents of a child who had an accident in the lift. If it didn't say anything about this is dangerous or that is dangerous, then they couldn't have prevented it. So AI assistant is just another device, like a car or a lift or something like that. When people know what these things can do and what can go wrong, then yes, of course, they should keep an eye on children and stop them doing dangerous things. If they don't know what can go wrong, then I think they are not really responsible.
Thank you. That really makes sense. I mean, one of the advantages of AI systems is there's a very, very clear audit trail in terms of the output. So do you think that the record keeping will be much better with AI systems in terms of the way the dementia patient is interacting? And do you think that can create some advantages?
It can. It is definitely doable. Just keep a recording of all interactions, or maybe even analyze it, try to learn something from it. There is, of course, the downside of confidentiality, privacy, whether people would actually be happy that all the conversations are recorded. So that's something to consider. Maybe depending on the stage of dementia, if somebody is having mild cognitive problems, maybe we shouldn't record all the conversations just by default. If somebody is in a stage when we can actually learn something useful and help them from keeping the recordings, then it's worth the invasion in privacy. I think that's also a say for the medical ethics committees and how much help can we give in this case. It's always proportional.
So we all have experience with GDPR and the evolution of assumed consents into positive opt-in consent when it comes to data sharing. So that takes me on to the new EU AI Act. Do you think its approach in the way it's classifying high-risk systems like those used in healthcare, is that going in the right direction? Do you think the EU is fully up to speed with the sort of systems that you're developing with colleagues like Ruslan?
I think EU Act is a very good piece of legislation. I think it's a kind of somewhat stopping dangerous use of AI. It obviously needs to be maintained and updated if some things become possible and they have great advantages, then like motion detection, maybe some things could be made exception. On the other hand, there are quite a few things that the Act allows that maybe shouldn't be allowed. So it's it's work in progress, but it's very, very positive development, I think, on the whole.
Very good, very good. One of the things that Rosalind talked about was when patients repeat the same story again and again, AI can perhaps spot differences which might infer things we wouldn't otherwise know about a person and their condition. And the fact that that can be recorded, do you think that's a good thing?
As I said, that's for medical ethics committees
Okay.
to decide. If this is something, it's a certain intrusion into patients' privacy. It's keeping their very personal data. But if this data is useful for helping them or even helping other people with dementia, then it's worth it. But that's the judgment that not AI people should make, for medical people to make.
Yeah. Or maybe both. Good. Okay. So let's now look to the future and the moral value of hope. I want us to talk about. So, in your view, in say 10 years' time, what would safe AI care look like? How would we know that we'd actually made very, very amazing progress in this, and that millions of older people in care are benefiting from that. What do you think that will look like from a safety perspective?
I hope that there would be a range of different types of AI assistants available, starting from kind of practical things for people who just need reminded of what they were about to do, what they've been doing yesterday, and maybe help with disorientation that happens sometimes. And so that's just a very practical thing, to the later stage dementia when people need comfort and soothing and just companionship when they can't be with another human being, which is always better. So there is a range of possible very useful things that we can come up with.
Yeah.
I don't
I'm
think there is one big sort of, yeah.
And I'm actually remembering when my late mother, who had dementia, the one thing that, brought the lights back in her eyes was when I was playing her music that she remembered, and she was able to sing along to it. And obviously that's something that this technology can do, that it'll
Yes.
know the songs that will wake them up and make them feel good. And that very simple thing, I mean, wouldn't that be amazing?
Yes, and Sarah Plus should be up to it.
That's
That's already
fantastic
now.
to hear.
Yeah.
I've got one last question for you, which is, if you could embed, if somehow we were able to embed one human moral value that perhaps is more emotional and rational deep inside every AI system, a bit like, I don't know if you watch Star Trek, but Commander Data wanting his emotion chip, which moral value would it be and why, if you could have that wish?
I think probably compassion.
Wonderful. Arthur Schopenhauer would be very, very happy with that answer. For listeners who are not aware with that, Arthur Schopenhauer said, compassion is the basis for morality. What a lovely answer to finish this very wonderful and enlightening Q&A. Natasha, thank you so much for joining us for this
Thank you very
episode
much for inviting me.
Well, it's been a delight. And for such an illuminating discussion on how logic, ethics, and compassion can come together in the design of AI. There are 3 takeaways for me. There are some serious privacy concerns in this area. These need to be at the forefront of the minds of developers, regulators, and of course, medical ethics committees. Patients will need to be able to trust the machines which look after them, and that trust will have to be earned, but also understood. And it's easier for robots to nag humans than it is for us. So what a wonderful set of takeaways. Thank you, Natasha. So that was Professor Natasha Allechina, helping us see how moral reasoning can guide the next generation of AI caregivers. If you enjoyed this conversation, please like, subscribe, and leave us a 5-star review. It really helps others discover the show. I'm Roger Steer. Join us next time on Chat Rog, where we look not just at what artificial intelligence is doing, but what it should be doing.